Hey guys, I am Leslie Bermundo, a third-year civil engineering student, and for this video, I am going to provide a solution on one of our word problems in our plate number 3 in reinforced concrete design subject. And this is about design of beam for flexure. But before that, I would just like to answer one of the frequently asked questions of CE students. Bakit nga ba kailangan lagyan ng reinforcement ang concrete? So we have this example, and from this given picture, we can notice na nagkaroon ng crack or ng failure sa ating concrete. And kapag ganito yung sitwasyon, we call it as compression control. Whereas kapag ganito naman, na nauna mo nang mag-bend yung ating beam bago magkaroon ng cracks yung ating concrete, we call it as tension control. So, between the two, better kung ang beam natin ay tension controlled, because if not, there is a high possibility of casualty dahil unang masisira ang concrete at hindi malabong mahulugan ang mga tao. So, proceed na tayo sa problem. Determine the theoretical steel areas required for tension of a rectangular section with B is equal to 350 mm, D is equal to 600 mm under a factored moment of 1,500 kN meter. If compression steel is required, assume it will be placed 70 mm from the compression fiber of concrete. Use Fc prime equals to 28 megapascal and Fy equals to 420 megapascal. Using a bar size of your choice, determine the number of bars required and design the bar layout. For the purpose of laying out, use 10 mm diameter bars for stirrups. So we have the following given, which is Mu is equal to 1,500 kilonewton meters, B is equal to 350 mm, D is equal to 600 mm, dB or our B prime is equal to 70 mm, Fc prime is equal to 28 megapascal, Fy is equal to 420 megapascal. And we are asked to determine the number of bars required and design the bar layout. So for our solution, our Mu is equal to 1,500 kilonewton meter. And with that, we are able to find our Mn because our 0.9 is already constant. So by dividing it, we have 1,666.6667. And solving for Mn, we can also have this equation, which is Mn is equal to ASFy multiplied to the difference of D and A over 2. However, our A is not given or not provided, so we have to solve for this. And using the equation, we have A is equal to 420 times AS all over 0.85, which is already a constant thing, multiplied to 28 and 350. And solving that, we have 0.0504 AS. And since we already have our value for A, however, this is not a typical value or a number or a quantity, pwede natin tong i-substitute dito sa ating equation. So, substituting, we have 1,666.6667 multiplied to 10 raised to 6 equals to AS multiplied to 420 times the difference of 600 and 0.0504 AS over 2. However, AS would be an invalid value. Therefore, we will be using or we will be making use of this equation wherein P is equal to 0.85 beta multiplied to Fc prime over Fy and times epsilon of C over epsilon of S plus epsilon of C. Substituting the given data, we have computed P is equal to 0.0361, wherein this is also equal to the quotient of AS and the product of BD. So, AS now would be 0.0361 times 350 times 600. And solving it, we have 7,586.25 square millimeter for tension. So since we already have our AS, we can now proceed, or we can now substitute this to our equation for A. And substituting, we have computed A is equal to 382.5 millimeters. Next is our A prime of S, because that would be for compression. So Mn is equal to 7,586.25 times 420 multiplied to the difference of 600 and 382.5 over 2. And solving that, we have 1,302.369 kilonewton meters, which is obviously less than our previously computed Mn, which is the 1,666.67 kilonewton meter. So to get our M prime of N, we have to subtract the values we have computed. And solving that, we have 364.301 times 10 raised to 6. So since we are free to decide for our own bar size, I have decided to use 28 millimeters. So in compression, we have 1,636.57 divided by the area, which is pi over 4 times 28 squared, and it is equal to 2.65 or 3 bars. Whereas in tension, 7,586.25 divided by the area, which is pi over 4 times 28 squared, and this gave us a value of 12.32 or 13 bars. And this is now the design. So if you can notice, there is a 13, so this is now the design, and kung mapapansin natin, meron tayong 13-28 millimeter bars under tension, whereas we have 3 28 millimeter bars under compression. And kapag ganito, we can say that this beam is doubly reinforced beam. So to paraphrase, in compression, there shall be 3 bars, whereas in tension, there shall be 13 bars. And that's it. I hope that you guys have learned something from this video, and I hope to see you on my next one. Bye!